Hello everyone, my name is Sarah, and in this video presentation I'm going to be talking about hybrid powertrain systems. To start us off, I'm going to go over a little bit of hybrid history. Then I'm going to talk about the different styles and types of hybrids that are available on the market today. And then to finish up, I'm going to talk in depth about the 2004 Toyota Prius. Hybrids have become a lot more common over the last couple of decades, and there's a few reasons for that. One reason manufacturers have been spending so much time focusing on hybrids is because of more strict emissions regulations that have been coming out from the government. Then you also have the fluctuating gas prices. It isn't as bad now, but in the late 90s, early 2000s, gas prices were getting quite high compared to what we Americans were used to. And then, of course, there's the mindset these days where, we are concerned about the environment. It's a misconception, though, to think that hybrids are a new thing. The first hybrid was actually developed back in 1901 by Ferdinand Porsche, and it was called the Semper Vivus model. The Semper Vivus used a gasoline engine, which provided mechanical energy to a generator, which changed that energy into electric energy and used that to operate the electric motors, which rotated the drive wheels. And this technology stuck around for a couple of decades back then as well. One of the later versions was the Owen magnetic in 1916. This was invented by a man named Justus B. Entz, and he was actually from New York. He worked with Thomas Edison in order to create this transmission. This transmission was made up of a 24-volt generator and an electric motor. And the cool thing about the Owen magnetic is that it introduced the concept of regenerative braking. That doesn't seem like a huge deal to us now, but back then regenerative brakes were really good compared to what was available on conventional cars. Most vehicles back then weighed between 3,000 and 4,000 pounds, and they only had rear brakes. If they got wet, you were pretty much SOL. But as I'm going to talk about later on, regenerative braking basically uses the electric motor to help slow you down while it charges the battery. So back then, it was great. The regenerative brakes could slow the vehicle down for them. They didn't have to rely on mechanical brakes that weren't so good yet. So as you can see, hybrid vehicles have been around for a long time. They're just becoming more common to us now. And we're getting to a point now where manufacturers can produce them for a lot less and make them more available to the market in general. There's a lot of different vehicles out there that qualify as being a hybrid vehicle. Manufacturers have come up with a sort of classification system in order to make it clear as to what sort of features you could expect on a particular model. The four most common classification terms are micro, mild, medium, and full. A micro vehicle is essentially your conventional gasoline engine vehicle with start-stop technology added on. It is interesting to note that even just with the start-stop technology, you're already saving up to 5% on your fuel costs. Obviously, if you are a city commuter, you're going to be saving more, or on the higher end, because you're going to be stopping at traffic lights a lot more often, whereas if you are, you live here in upstate New York, probably not as much. Next, you have mild hybrids, and really the biggest difference between mild and micro hybrids is that the electrical motor is able to assist the gasoline engine, and the fuel economy improvement for a mild can get up to 10%. The medium classification isn't as commonly used. Any hybrid that kind of falls in between that mild and full stage could be considered a medium hybrid. At this point, you start to see the downsized engines, and the fuel economy improves even more to up to 20%. With a medium hybrid, there's significantly more going on electrically, but the vehicle still cannot be propelled by the electric motor alone, at least not from a stop. Full hybrids are the only classification in which the electric motor can propel the vehicle from a stop by itself. And the fuel economy improvement can get up to 30%, which is very significant. Now, there are two main types of hybrids, and those would be series and parallel. Now, those terms might sound a little familiar to you. If you recall from basic electrical, you have series circuits and parallel circuits. In hybrids, it's very similar. In a series hybrid, everything is pretty much a straight line. The engine that is going through an inverter to charge a battery, which is powering the motor, which is driving the wheels. Some advantages of a series hybrid system is that it can use a smaller engine, and this engine can run at its most efficient RPM at all times because it isn't directly connected to the drive wheels. It has nothing to do with the drive wheels. The motor takes care of all of that, so all it has to worry about is charging that battery. And it's a pretty simple system too. In a parallel hybrid, on the other hand, the engine or the electric motor may drive the wheels, and this can happen in any combination, really. Some advantages to this is that there are less electrical components, which could result in an overall lighter vehicle. And another advantage is that the engine can supply the extra power if you need it, when you need it. Unlike the series hybrid, which only has that electrical motor, and if the electrical motor doesn't have enough juice to get you up that hill, then there's not a whole lot the vehicle can do to help you out. Now I'm going to get into detail about the 2004 Toyota Prius. Now the Prius is an example of the third style out there for hybrids, and that would be the series parallel or Powersplit hybrid. Basically all this means is that the powertrain system on the Prius has the ability to run as either a series or a parallel system. Toyota launched the Prius in 1997. And it was the first widely available hybrid on the market. Its drivetrain consists of an internal combustion engine, 2 or 3 electric motors, depending on whether or not you have four-wheel drive, a planetary gear set, which is referred to as the Powersplit device, an inverter, a battery, and of course the computer module that controls everything, the ECU. The 2004 Prius uses the 1NZ-FXE engine. This engine is an Atkinson cycle engine. Most conventional vehicles use what is called an Otto cycle engine. What's different about the Atkinson cycle engine is that it varies the amount of piston movement in order to increase efficiency. Early on in the Atkinson's development, this was done with a series of complicated arms, as you can see in this animation. Nowadays, it's done by delaying the intake valve closure so that during the compression stroke, some of the air-fuel mixture gets forced back into the intake manifold. This mimics the effect of having a shorter compression stroke than decompression stroke. And what this allows the engine to do is get the most energy out of the fuel as possible. But this also limits the power output that the vehicle is capable of. Now, in a conventional vehicle, this loss of power would be noticeable. But with the Prius, the electric motor is able to compensate for this loss of power, so the driver doesn't even notice it. Now I'm going to talk a little bit about the electric motors used in the 2004 Prius. These motors are referred to as MG1 and MG2. MG1 is the smaller of the two electric motors. This is the motor that is mostly responsible for recharging the high voltage battery. During certain driving conditions, it also supplies electric power to MG2 and is used as the starter motor for the engine when that turns on. So essentially, MG1 acts as the vehicle's starter as well as the vehicle's alternator. We'll talk about it in depth later on, but MG1 is also the control element for the ECVT. The gear ratio of this transmission can be adjusted by changing the RPM of MG1. MG2 is the larger of the two motors. This is the motor that's responsible for providing drive power to the wheels. When the vehicle is traveling at higher speeds, it supplements the power that the engine provides. Because this is the motor that is directly connected to the wheels, it is the one that is also used for regenerative braking. Speaking of regenerative braking, let's go over that really quickly. Now, the whole purpose of regenerative braking is to make your vehicle more efficient. If you recall from your physics class, energy can't be created or destroyed, it just changes form. Your internal combustion engine takes chemical energy and turns it into mechanical energy. That mechanical energy goes through the transmission system and ends up being kinetic energy as it gets to the wheels. When you slow down your vehicle, that kinetic energy is turned into heat energy. And once it's in the atmosphere, it's gone. You can't use it anymore. Regenerative braking helps remedy this by using an electric motor to help slow the vehicle down, in combination with the brake pads. The same motor that's used to drive your wheels can be used as a generator under decel or braking conditions. When your motor is being used to drive the wheels, it is receiving an electrical current from some source, whether it be a battery or whatever that particular vehicle happens to be using. That electrical current creates a moving magnetic field which rotates the rotor inside the motor. This gets your wheels moving. Now, when you're decelerating or braking, the opposite happens. The motor is no longer receiving a current from an electrical source. Instead, the kinetic energy of your vehicle keeps the wheels turning, which in turn continues to rotate the rotor inside the motor, which generates a voltage in the stator coils. This voltage is what goes back to charge the high voltage battery. One of the added benefits to this is that because the motor is helping to slow your vehicle down, there's less wear and tear on your brake pads. Now, the brake pads are still there. Obviously, if, for some reason your regenerative braking system fails, they're there to back you up. And also, the motor cannot provide enough stopping force in an emergency situation. Like, say a deer jumps out in front of you, the motor's not going to be able to stop you in time. So your vehicle would still use conventional brake pads in that case. So just a couple more details about the motor generators. Both of them use permanent V-shaped magnets in the rotor. These magnets are new as of 2004, and changing to that shape added about 50% power versus the horizontal magnets in previous models. And both of the generators also have what is called a speed resolver on them. These are disc-shaped sensors, essentially, and speed resolvers consist of an oblong-shaped rotor that rotates along with the generator, and the sensor that has 3 coils, about 90 degrees off of one another. Now, as the rotor spins, the oblong shape produces a pattern in the current, so the ECU can tell exactly where that generator is in its rotation. Now I'm going to talk about the Powersplit device used in the 2004 Prius. Now, the Powersplit device is, as you can see here, just a simple planetary gear set. Now, the ring gear is what MG2 is splined into. This outer ring is mechanically connected to the wheels, so when this is moving, your car is moving. The planetary carrier is what's connected to the engine. Now, the ECU is able to keep the RPM of the engine constant while it varies the RPM of MG2. This is so that the ECU can keep the engine operating at its most efficient speed. Now, if this planetary carrier isn't rotating, so it's not moving, that means the engine is off. The planets will still rotate, obviously, but if the carrier itself is still, then you know the engine is off. And finally, the sun gear is the component connected directly to MG1. Now remember, MG1 helps to start the vehicle, it's used to charge the battery, and it's also used to help maintain a proper gear ratio, as you'll see in just a second. I'm going to go over different driving scenarios. This is what it looks like when the vehicle is performing a light acceleration from a stop. Notice MG2 is providing all of the driving force in this situation. The internal combustion engine is off, and MG1 spins in the opposite direction because it doesn't really have a choice. If it moved forward as well, the gear set would bind up. It's important to note MG1 is just freewheeling. In this case, it is not producing electricity. So this is what it would look like with a normal driving condition. The internal combustion engine has turned on at this point, and MG2 is providing assistance with providing the vehicle the proper amount of power. MG1 is rotating in the opposite direction still at a lower RPM. I exaggerated this a little bit just so it was easier to see. But MG1 is providing electricity at this point, and that electricity is going to support MG2, so that MG2 can do its job without drawing on the battery as much. Now this is what it looks like in a high-speed cruise or full throttle condition. At this point, all three gear components are rotating in the same direction, and that's because MG1 is now receiving electrical current from the battery, so that changes its rotation direction. MG2 is also receiving electrical current from the battery. It is providing assistance to the internal combustion engine so that the engine can continue to provide the power it needs to provide without getting out of the green zone and into the red inefficient zone. Now, MG1 rotating in the same direction means that it is now helping to create an overdrive gear ratio so that it's easier for the vehicle to maintain its higher speed. This is what it looks like when the vehicle is decelerating or braking. As you can see, the internal combustion engine has turned off, and because the planetary carrier is no longer rotating, MG1 has no choice but to rotate backwards. MG1 in this case is not providing any electricity, it is just idling. And MG2 is continuing to rotate because of the inertia in the wheels. And because of this, as you recall, when we just talked about regenerative braking, that's what's happening in this case scenario. MG2 is being rotated not because it is receiving current, but because of the momentum that is still in the wheels. As that momentum is used up, MG2 will continue to slow down, and then eventually the brake pads will take over and stop the vehicle. That's close enough. You get what I'm saying. Now in reverse, the internal combustion engine remains off. All of the drive power comes from MG2 in this case. And MG1 is, again, just idling. It's not producing any electricity. While I have this diagram up, I want to show you guys what I meant when earlier I called this an electronic CVT. Now, CVT stands for continuous variable transmission. It means the gear ratio has limitless possibilities. I mean, most conventional transmissions, the gear ratios are fixed. So you have, 3 to 1, 1.5 to 1, stuff like that. A CVT transmission can pick and choose its exact gear ratio for any driving condition. And this is an electronic CVT because, as you can see, all I have to do, look at all of this. Just sliding this, you can see the differences. Here you've got, if you needed an underdrive, there's an underdrive. There's your overdrive. Oh, if we go too far, it goes backwards, but it's just all of these are, the ECU has complete control over the exact gear ratio in this carrier. So that's what I mean when I call this an electronic CVT. For the last two components, you have the inverter and the high voltage battery. Now the inverter is essentially just a translator. It takes alternate current and changes it to direct current for the components that need it, and vice versa. And the high voltage battery is essentially just a power storage unit. It stores electricity recovered by MG2 while regenerative braking is taking place. It stores power generated by MG1 in normal driving conditions, and it also supplies power when the vehicle is starting or when additional power is needed, such as in a full throttle or high-speed cruise condition. Hybrid powertrains is a extremely broad topic, and there was a lot to talk about. Just to recap what we went over, I talked a little bit about hybrid history, different hybrid levels and types, and I also went over some of the drivetrain components in the 2004 Toyota Prius. I could talk for hours about hybrid vehicles. There is so much information out there and so many different ways that manufacturers approach these types of vehicles. Hopefully you learned something. I know I definitely learned a ton doing this project. Thank you for watching, and if you have any questions, please feel free to ask. I have a list of my sources in the description below, and thanks again.